The robots are here. Our future is no longer science fiction.
It's not 2050. It's not a scene from a science fiction movie. Right now, in mid-2025, a nation has quietly been building the future. Not with promises, but with real products. Commercial flying cars, robots running marathons, AI chips 30% cheaper than Nvidia's, and quantum computers powering the world's first secure international communication link. While many Western countries are still debating ethical guidelines or perfecting AI models in labs, China has millions riding in driverless taxis, running homegrown software on operating systems independent of Android, and testing non-invasive brain-computer interfaces. The question is no longer can they do it. It's is the rest of the world ready to live in this new reality? Not with pledges, but with data, devices, and business models already in operation. From robotics, AI, and quantum computing to clean energy, and signs that the geopolitical tech map may be redrawn, not through summits, but through code. Join Unknown Universe as we unpack 8 tech fields where China is reshaping the global game. 1. Multidimensional transportation. Imagine booking a ride on an app and minutes later an autonomous flying taxi takes off to pick you up. Noisy propellers, no emissions, no traffic jams. This is no longer fiction. In 2025, the EHang 216S, an electric vertical takeoff and landing EV-to aircraft developed in China, has entered commercial service in Guangzhou and Hef following over 10,000 passenger test flights. Each flight lasts approximately 21 minutes with a top speed of 80 miles per hour, 130 km/h, and a range of 19 miles, approximately 30.5 kilometers. Notably, charging currently takes 2 hours, though the company is working toward fast charging tech. 10-minute charging remains a goal, not reality. On deployment scale, EHang has secured orders from at least 7 countries, totaling over 1,200 units, including Malaysia, Indonesia, Japan, and some European nations. Claims of 18 countries remain unverified, but the tech international reach is clear. Meanwhile, on the ground, another revolution is unfolding. China has green-lit large-scale driverless robo-taxi operations in major cities like Shenzhen, Beijing, and Wuhan. Led by companies like BU, Apollo, and WeRide, these robo-taxi systems have logged over 7 million rides, a figure dwarfing US trials where Waymo hit approximately 250,000 weekly trips by April 2025. What's driving the buzz? Fares are 3 times cheaper than traditional taxis, and notably, no serious accidents have been reported after over 20 million miles of operation. With EVOS, China is turning flying taxis into an industrialized product, outpacing Western nations still grappling with safety regulations. With robo-taxis, they've optimized a commercial model rather than stopping at tech demos, paving the way for driverless urban futures. From ground to sky, China is building a 3D transportation ecosystem where data, AI, and electrification merge into a flexible, affordable, low-emission mobility network. This is just the start of a world where smart neighborhoods extend beyond the horizontal into the skies. Second, humanoid robotics. While much of the world still sees humanoid robots as trade show novelties, China has deployed them on actual production lines. In 2025, the Unite G1, a compact humanoid robot, became a social media sensation, not just for viral dance moves, but for its $16,000 price tag. Compared to Boston Dynamics Spot at $75,000, the G1 is nearly 5 times cheaper, making robots, once lab-exclusive tech, accessible to small businesses, universities, and even independent inventors. This isn't just a product. It's a sign of a new wave of affordable commercialized robotics. To grasp this shift, look at BYD, China's largest electric vehicle maker. At his Hef factory, 97% of processes are automated with over 1,200 welding and assembly robots, installing 4 tires in just 48 seconds. And that's just one plant. With nearly 1 million employees, BYD aims for 500 robots per 10,000 workers by 2025, roughly 50,000 robots across its system. Observers believe BYD is close to or has met this goal given its heavy investment, rapid production scaling, and internal humanoid robot initiatives for factory environments. This is a rare blend of low-cost large-scale production and real-world application. It's allowed China to close the gap with leading humanoid robotics firms, not by matching the highest tech, but by democratizing tech at the market's lower tier. And often it's this mass market segment that drives profound change. In factories like BYD's, robots don't just weld or assemble. They learn and adapt. This is where AI, smart manufacturing, and humanoid robotics converge to create a next-generation production ecosystem where every worker is backed by a silicon colleague. 3. Made in China AI. 2025 marks a surprising leap for Chinese artificial intelligence. Not through a new chatbot, but by building a complete AI ecosystem spanning chips to algorithms, labs to commercial products. DeepSeek R1 Super mathematical reasoning model with 671 billion parameters. DeepSeek R1 is pushing AI's mathematical reasoning to new heights. In standard tests like AIME and Math 500, it scores approximately 80%, nearly matching top US Olympiad students. What's notable isn't just the result, but how it's achieved. DeepSeek uses a mixture of experts architecture, activating only 37 billion parameters per inference, optimizing resources, and cutting operating costs by up to 95% compared to US models of similar size. This means a massive model that's still accessible from a laptop or gaming PC via a compressed version. QW30B. Powerful, affordable, runs on gaming rigs. If DeepSeek R1 is for labs, QW30B or QWQ32B is AI for the masses. With 32 billion parameters and a cost of approximately 0.2 per million requests, this model is designed to run on consumer GPUs like the RTX 490, letting startups or individual developers tap advanced reasoning power. Notably, QW30B's performance rivals DeepSeek R1 on many math benchmarks, showing that bigger doesn't always mean smarter. China is prioritizing efficiency over size. Ascend 91B homegrown 7nm AI chip. Behind these models is a less noticed but critical step. Domestic AI hardware production. The Ascend 91B, a high-end AI chip developed by Huawei and made by SMIC on a 7nm process, reportedly matches NVIDIA's H100 in performance, though debates persist over yield, approximately 20 to 30%. Technically, it's larger with lower transistor density than TSMC's chips, but its existence amid EUV shortages, equipment sanctions, and EDA restrictions is what matters. The story of DeepSeek QW30B and Ascend 910B isn't isolated. It's about coordination across models, software, and hardware, forming an independent supply chain that functions with or without Western support. China doesn't just want a local ChatGPT. They're rewriting the AI production model from chips to cloud, devices to training. And if you think this only matters to AI engineers, think again. If Chinese AI runs better, cheaper, and independently of US ecosystems, the next AI app you use might not come from Silicon Valley, but from Shenzhen. 4th, brain-machine. Brain-machine interfaces and biotech. If you think brainwave communication is still sci-fi imagery, think again. In China, it's leaving the lab. BrainTalker, turning thoughts into digital signals. Launched in 2019 by Tianjin University and China Electronics Corporation, BrainTalker isn't a complete device. It's a specialized chip designed to help brain-computer interface BCI systems decode brainwaves faster, more accurately, and with less power. The goal is clear. Enable stroke or paralysis patients to communicate via thought without surgery or physical movement. One day instead of typing we might just think and computers will understand. However, claims of 50 words per minute without implants remain unverified. Recent studies suggest non-invasive BCI systems using EEG achieve approximately 10 to 12 words per minute. Faster systems reaching 78 words per minute typically require surgical electrode implants like Stanford's experiments. BrainTalker is non-invasive, and if it truly hits 50 words per minute, it would be a global breakthrough. For now, it's more potential than proven. claims that BrainTalker is 100 times more effective and uses 1,000 times less power than older devices may hold if compared to early analog systems or non-optimized chips. Though speed and efficiency debates persist, the tech direction is clear. China aims to use BCI to restore communication and mobility for stroke patients. Systems like the US's Ipsei Hand use non-invasive BCI to control prosthetic hands for stroke patients. But BrainTalker promises to do so at a lower cost without complex external devices. If this tech advances as planned, affordable, safe, high-performance BCI could become a global standard for rehabilitation. The thrilling and slightly unnerving possibility is if chips like BrainTalker work well, we might ditch keyboards, mice, and touchscreens. Imagine a future where emails are sent by thought, navigation is driven by intuition, and paralyzed individuals communicate normally. That's not 2050. It could be 2030 if tech like BrainTalker goes mainstream. Fifth, quantum computing, encrypted communication and encrypted communication.